All right, guys, this is a quick little review slash help video on section 4.5. This section is very similar to 4.4. It's just reinforcing the fact that our arithmetic sequences are linear functions or straight lines, whereas our geometric sequence, our multiplication sequences are really just exponential functions. Now, sometimes we do have those weird oscillating functions we've seen, but they're still just exponential functions, okay? So when you get onto section 4.5, you'll notice this first handful of problems are pretty straightforward. Instead of just giving you a chart to fill in, they give you the arithmetic sequence. You turn it into what is literally just slope-intercept form and then graph it. You're going to do this by putting this into the table. Okay. Now you can't just put the original into the table. I get that, but as far as EOC goes, you really need to be able to take this arithmetic sequence and convert it into slope-intercept form. So that's really the focus and the practice today. Okay. Now also, please make sure you're still scaling your graphs correctly. Yours may not end up looking as perfect as these do on every single one. I'm okay with that. Make sure you're counting by normal numbers over here on the sides, 10s, 20s, hundreds, things like that. Okay. And usually just 1 through, not even usually, always just 1 through 10 down here on the bottom, starting with term 1. Okay. That's the first handful of problems. It's pretty straightforward. What this video is really concerned with is that, of course, in typical Carnegie fashion, it starts off with something pretty easy, and then it gets into problems like number 7. And the big jump here is that we're going from geometric sequences, which are exponential. Now, there is a little example here, okay? And you can just carbon copy this all the way down, okay, for your next few problems. But I wanted to give you a little bit of an explanation as to why and how this happens. And yet it's still going to require a little bit of just, hey, trust me, there's some magic voodoo happening. Let's take a look at number 8 on your skills practice, okay? This is number 8 on your homework. So I'm essentially, for anyone watching this and really paying attention, I'm doing a problem for you, okay? And this is the geometric sequence that you're starting with. Our final goal, and you'll see it's here this whole time. I always keep that in mind. Remember, we always keep our final goal in mind, okay? Our final goal is to have an exponential function. This is the way right here on the left that your formula sheet has exponential functions. But a lot of the time we've seen them written out like this with the multiplication sign in the middle. That's a good reminder that you can't actually put these two AB terms together. You can't multiply them together because of this exponent. And when you look at our geometric sequence, you'll notice we're really, really close, or at least it looks that way, that we're really, really close. The big problem is in this underlined red section. That's a binomial in the exponent, the n minus 1. We've seen that a lot. And that's an issue. You can't have that in an exponential function, okay? So we got to do something about that. This first step is the only time I'm going to basically just say, hey, trust me, it always works this way. You can actually break up a binomial in a exponent into 2 pieces. An n piece, you can see the positive n just stayed positive n, same base, 3, so 3 raised to the n, times 3 raised to the negative 1. So I took this binomial and I just broke it up into its individual pieces. Please notice the base stayed the same for both pieces, 3n and a 3 to the negative 1 power. I know, don't get confused with this negative 3 out front. That really could be any number at all, okay? If this was a negative 5, it'd be a negative 5 here, okay? That has nothing to do with this breakup here. This breakup is just a 3 raised to the n minus 1 breaking into a 3n and a 3 negative 1, okay? That's the only thing that's changed, all right? Now, the next part's going to look a little bit like voodoo, like something just magically happened, but we can check this, and I'm going to show you. This is actually always true. Something raised to the negative 1 power, it just flips that fraction. So now a common theme in Algebra 1 is we've really had to get used to these fraction manipulations, and this is just another one, okay? I'm going to show you, though, that this is not just random that this happens. Check. 3 raised to the negative 1. Well, you can put that in your calculator. 3 raised to the negative 1. And it gives us this. You say, oh, Mr. Rowe, you said it was going to be a third. Well, watch this. Math, enter. It is. It's just 1/3. Yes, it's that repeating crazy decimal, but if you do the math, enter, to convert it to a fraction, it tells you that it's just 1/3. It works for any number. If we have 5 raised to the negative 1 power, okay, I'm thinking, oh, that should be the flipped fraction, 1/5. Well, I hit enter. Oh, I get 0.2, but we check and convert that. 1/5. Doesn't matter. It could be a crazy number like 17 raised to the negative 1 power. Well, that's going to be some ugly decimal, but whenever we convert it into a fraction, it's 1/17. So that's not just, hey, trust me math. That's actual a real useful math rule that's going to carry really on into your advanced algebra sort of days in high school, okay? And anywhere further on. Anything raised to the -1 power is just the inverted fraction. Now, please notice this 3 to the -1 power became a positive 1/3. Please don't get those signs mixed up and start telling me -1/3. The negative power is what flips it, because 3 to the 1 power would be 3, but 3 to the -1 power is 1/3, okay? Now, why is this useful? You said we still got 3 parts, Mr. Sorrell. In fact, it looks worse than it did to start with. Well, these two pieces, -3 and a positive 1/3, these, since they don't have exponents on them, can be multiplied together, okay? Whenever we multiply a -3 and a 1/3, if you don't believe me, throw that in the calculator, okay? -3, whoops, that's -33, okay? -3 times alpha y equals, enter, that's how we get our fraction bar. 1/3 is going to give me that -1. And whenever I multiply those together, sure enough, -1 times 3 raised to the n power. Remember, do not put these together, okay? Do not, because this one has an exponent. We can't multiply these together. It's not going to become -3 raised to the n. It's got to be -1 times 3 raised to the n power. So this is our exponential function. If you want to then go graph it, okay, you simply hop over here into your calculator, clear out whatever junk someone's left in there from a different class. -1 times 3 raised to the n power. Remember, we don't have the letter n, but you see it right here, so I can just use that letter x. If you want to graph it, you can graph it, but really what we're interested in for our sake, because we're graphing this by hand, is the table. Pop over in the table. This would be our first term, would be -3. Our second term would be -9. So these are our points. 1, -3, 2, -9, 3, -27, and so on and so forth, all the way down to this last point. And again, remember, these geometrics get out of hand really fast. So when you're going to create your graph, you may not be able to get this point down here at -60,000. That may not fit on there. Just do your best to scale it and get as many of the points on there as you realistically can. So if I'm thinking as many as I can, maybe I can only get down to this 8th point. Okay, so maybe I count by 1,000s. That's going to make it really tough to see these first points all the way up really until here. It's going to be really hard to see. So maybe you just go to this point and kind of count by, 200s. That way this last point kind of hovers down below the graph because it's lower than 2,000. But these other ones you can kind of see better. Use your better judgment. Do your best on the actual graphing. Remember, it's not an exact science. You're just kind of plotting out the points. Please refer back to this video and use this little trick. Okay, that's going to really help you with those geometric sequences.